I am joined now by Nick Radford, who's the Deputy Project Manager for Robonaut here at the Johnson Space Center. You and your team, Nick, have been watching along this morning as Dan sort of checks out Robonaut, make sure that the joints are working and everything. So it's got to be pretty exciting for your team to see all this actually happening today.
Yeah, absolutely. It is incredibly exciting from our point of view. This is actually today was pretty monumental. This was the end of a long series of checkouts that we've been going through, trying to get all the degrees of freedom or the places that the robot can move up and running. And so over the last 4 or 5 times we've been running it, we've been incrementing our way towards that. But just finally today we've been able to run all the degrees of freedom of the robot. We got all of them to move, and they're checking out very successfully. So yeah, it's a very exciting time for the ground controllers.
So what is Dan going to be doing today? He's basically going to be moving the joints around, like you said, the degrees of freedom, making sure they bend like they're expected to, and then he's going to do sort of like a force test or something on the forearms, right?
Yeah. So after we just completed all the checkouts of the joints, Dan is now going to go through, and we've got force sensors all over the robot. The joints themselves measure force, and there's actually force sensors that are cross-checking those. So what Dan is doing is he's making sure that those values are reading as we expect them. They're going to read within the limits that we need them to, and they're helping us determine, characterizing the lack of gravity that obviously isn't there, and so it's giving us all the scientific insight that we need to make sure that all the safety systems of the robot are working properly.
Okay, so there's a task board. Like let's explain this for the public. There's a task board that basically once everything gets checked out on Robonaut, then he's going to be kind of doing his own sort of thing with his project board that's in front of him. Can you kind of talk a little bit? I think we've got some video of it, but
Sure.
but kind of talk to that about what he's going to be doing once you guys kind of give the stamp of approval on him.
Right, so we've been using this task board on the ground to essentially program in the behaviors and the reflexive behaviors and the knowledge that the robot needs in order to do useful work for the crew. Ultimately, that's our goal is to make sure that this robot can assist the crew in ways that are going to aid them. And so we've got a variety of things up on the task board: buttons and switches and levers and buckles and straps that you're going to find on the space station. And so what we're doing is we're doing research on the ground in order to program in the intelligence to the robot. Well, what we need to understand is how things change in zero gravity. The first series of checkouts that we did with the robot were actually tuning the gains for the robot for the differences of one gravity that we have down here on Earth and the zero gravity that the crew operates in. So we need to repeat what we've learned on the ground in orbit, making sure that there's no surprises and that everything's going to work properly.
So we're seeing it here. This is exactly what he'll be doing in space, right?
Yeah, so the crew does a variety of things that that are that cover the gamut of the mundane to the crazy exciting, right? And what we're trying to do is help the crew, relieve them of some time that they don't need to focus on the things that are just housekeeping types of activities. For example, one of the activities that's coming up is to take air velocity measurements with a VelociCalc. Well, the crew, has to spend a certain amount of their time taking these air measurements. And when they take these air measurements, they have to hold really still. And so robots can hold really still really well, right? And so this tool that the crew uses was designed for a human. It's got buttons, it's got a handle, and having a robot that has the same type of shape and form of a human can just straight away use the same tools. And so now we're going to offload that activity to the robot, so we can get the crew back into the science-related activities where they're not just checking air quality for the space station, or they're not, housekeeping the space station. They're onto the science that we want them up there doing. And so this relationship between the crew and the robot is going to prove incredibly valuable in the future.
What are the lights that you see in his hands there?
It's pretty much bling, really.
Okay.
So they're indications that are certain electronics in the boards are reading the sensors in the hand. So the hand is this incredibly sensate device. It's got just as you can have an incredible this incredibly delicate sensation of feeling when you're touching things, and so does the robot. And so what really sets this robot apart from other robots you might see is its ability to perceive forces in its, from interacting with its environment.
Okay.
So if you want to actually do anything, and what we've really designed this robot to do is to do work. So if you actually want to do anything, you have to have this perception of forces. And so, this robot can grab something and based on the tactile information it's getting in its hand, estimate the pose of that object. So, whether it can tell whether it has a good grip, whether it needs to change its grip, what the size of the object is, the orientation of the object. And so this robot is just full of all those types of sensors.
It really can touch.
Yeah,
It
absolutely
can
can
feel.
touch. It can feel. Yes.
That's fascinating. Let's talk about the design of it, because I think the first time I ever encountered this was here in our mock-up facility here at the Johnson Space Center back a couple of years ago before it ever flew. And one thing that you guys taught us, which I found very interesting, is that it looks humanoid, but that's for a reason. It's not just because it looks cool. It's because once you start adding stereo vision, you've got 2 cameras, and so it starts to kind of take on a human shape.
Exactly. So the anthropomorphic shape of the robot is absolutely by design, because we've designed a robot to interface and interact with all the same tools and the same structured environment and just all the same objects that you and I do. Well, we've adapted our environment to the human form. So what we don't want to do is design a whole new set of stuff for our robot, right? So, for example, space tools. There's a lot of money in space tools. NASA has a huge investment in the qualification of these tools. So you could go build a robot and then go build a whole separate suite of tools, or you could build a robot that just happens to be able to use the same tools that the crew does.
Same form.
Yeah, the same form. And plus, when you're interacting with the robot, you have this sense of, you have this intuitive sense about how the robot's going to move when it looks like you. If it was some odd-shaped robot that was optimized for some specific task, you might be a little uneasy when you're trying to work with it, because it's not going to move in an intuitive way. And so when it's got 2 hands and 2 arms and a head that sits right above its shoulders, when it hands you something, you know exactly the motion that it's going to give you that object with. And so that sense of security and comfort is very important to us designers, because we want the crew to use this robotic tool, and we want them to use it a lot. And so it needs to be comfortable for them to work with.
So let's talk long-term plans. What, 5 years down the line, what would you see Robonaut doing?
We are very interested in, and we're very motivated to get this robot in an EVA setting. And so what we're doing IVA right now is preparing for that. And we're putting the robot up in a more of a structured environment, being able to place objects near it, being able to investigate how the robot's interacting with things. And we're going to prove out the operational concept of this robot IVA to show its value that it'll have EVA. With the absence of the space shuttle, the crew has a very limited EVA schedule coming out of the space station. And what we feel might be very advantageous for the crew is to have a robot resident on the outside of the space station that the crew could operate. And so now you don't have to save up all these different activities and knock them all out at once, or if you have some sort of emergency situation, you might be able to get the robot over to the situation and just look at what's going on quicker than what you could suit up an EVA crew member. So we really feel this robot has incredible value once it's EVA, and to kind of be a remote pair of eyes for the crew and a remote pair of hands.
Now you guys can actually command this from the ground, or the crew can operate it.
And we've actually been trading that on and off today with the crew. So we've been commanding it from the ground, and the crew's been commanding it from orbit. So there's been this kind of delicate ballet back and forth. It just depends on what's easier. And we've been proving that concept out of how to interact with the crew and how we command it on the ground. So yeah, we've been trading back and forth quite a bit.
Okay, so here's my non-technical question of the day. Whenever you guys command this thing, is it in real time? I mean, can you actually steer it in real time, or is it something you have to kind of input some commands into, and then it gets sent up, and then there's sort of a delay? I mean, can you actually, for lack of a better word, drive it in real time?
Yeah, so the direct teleoperation mode that you're talking about, we can do from the ground, but the time delays are such that, it takes a few seconds to communicate with the space station once you go through all the communication hops. It's not a real practical thing to do. Now the crew has teleoperation gear on orbit that they can put on and drive the robot in the same fashion that you're talking about. And we could do that on the ground, but the time delays would make it a little impractical.
That's very cool stuff. Well, we'll keep following along as Robonaut gets checked out today, and we'll have an update for you tomorrow here on ISS Update. So Nick, thanks so much for coming by.
Thanks, Josh, for having me.